In this video, I'm going to be doing some simplifying and solving equations, things that you're going to run into in this chapter on graphing. So let's go ahead and get started. If you look at, and by the way, I would encourage you to try all the problems here and then watch the video and see how you did. So on number 1, this is 2 pi divided by 2/3. This is what we call a complex fraction, where you have a fraction within a fraction. But really, you can just think of this as division. This is 2 pi divided by 2/3. And I'm going to go ahead and write pi, 2 pi over 1. This can be written as 2 pi times the reciprocal of 2/3, which is 3/2. So dividing by a number is equivalent to multiplying by its reciprocal. So now you can multiply across and you'd get 6 pi over 2, which is going to reduce to 3 pi. You could also cancel, divide by 2 here, and you can see you're left with 3 times pi, or 3 pi. All right, on number 2, we're solving for b. And so since I have a fraction here, I'm going to go ahead and clear fractions by multiplying both sides by b. Doesn't matter which side you put the b on. So notice when you multiply here, the b's cancel here, and you're left with just 2 pi over 1, or 2 pi, equals 4 pi b. But I'm solving for b, so I need to divide by 4 pi, since it's b times 4 pi. And notice the pi's cancel. And of course, 2/4 reduces to 1/2. All right, on number 3, and in all these problems, you're going to need to get a common denominator. So I want to write this as 2 pi over 1, and I want to rewrite 2 pi over 1 as a fraction that's equivalent to 2 pi, but has a denominator of 4. The way we do that is we multiply the denominator by 4. So we'll do the same thing to the numerator. This is negative pi over 4 plus 8 pi over 4. Now notice 8 pi over 4 is still 2 pi, but now we have the common denominator, so we can add our numerators. A negative 1 pi and 7 pi, that's going to be, and 8 pi is 7 pi. And so you get 7 pi over 4. All right. On this one here, I'm going to go ahead and first multiply here. So I'm going to have 1 times 2 pi, which is 2 pi, over 4 times 3, which is 12. Now keep in mind, I could have divided out a 2 here, or canceled out a 2. I'm going to go ahead and do it in this last step here. Well, actually, let's see, I could, it really doesn't matter. I mean, I could have done that and I'd have pi over 6 here, so I would treat it a little bit differently. I'm going to go ahead and just multiply by 4 over 4 here, so that I can get a common denominator of 12. I have negative 4 pi over 12 plus 2 pi over 12. Negative 4 pi and 2 pi, that's going to be negative 2 pi over 12. Whoops, 12. And if you divide out the 2, you're going to get minus pi over 6, or negative pi over 6. So that's not the only way to do that, but that's what you should end up with, no matter how you ended up simplifying here. In fact, in this case, we would do something similar there. We need a common denominator. It's going to be 6. So I want to multiply by 3 here, so I'll do the same to the numerator. Basically, what makes this work is that we're multiplying by 3 over 3, which is just another way to write 1. We call this building fractions. And so we get 3 pi over 6, which is equivalent to pi over 2. but now we have the denominators the same. This is negative 1 plus 3, which is 2 pi over 6, which reduces to pi over 3. Just divide by 2 in the numerator and denominator. All right, last problem. So if I'm trying to solve for x, first of all, I want to get rid of this term here. So I'm going to add pi over 5 to both sides. You're going to have 3x is equal to pi over 5. Now, there's two ways to think of this. You could take or divide both sides by 3. But if I divide a fraction by 3, I'm going to end up multiplying by the reciprocal. Another way to do this is just think about multiplying by the reciprocal of 3, which is 1/3. Oops, that's a 1. So when you multiply reciprocals, you always get 1. So 1x, that's just x. And I'll multiply the other side by 1/3, and you get pi over 15. So again, that's not the only way to do that problem, but that's one way. As long as you're getting pi over 15, you're good. And in all these cases, we're just using our algebra skills, and there may be other ways that you do it, and that's fine, but you've got to be able to deal with expressions like these and also equations like these in Chapter 4. So I hope that helps.